Hello students, welcome back to my channel Kasturi Shekhar Sir Classes for CA and CMA. Today I am introducing a chapter Transportation in Production and Operation Management. The name of the chapter is Transportation for Production and Operations Management. Let's see the introduction of this. A manufacturer is producing a single product at M factories. These factories are known as source. These goods are then be supplied to N storage locations. Each source has a known available supply and each destination has a known required demand. Okay sir, let us see this point once again. Goods are manufactured at different places. So the places where goods are manufactured we are calling as factories. How many factories are there in our example? M factories are there. Okay. The goods which are produced at these factories we are supplying to various places. So those are known as storage locations, or you can say destinations. Remember one point, in this example the manufacturer is producing a single product. Okay sir. In addition to this, what is given? Each source has a known available supply. Each source has a known available supply and each destination has a known required demand. Is a known required demand. In addition to this, one more point is given. If the cost of shipping a single unit of product, cost of shipping a single unit of product from each source to each destination is known, that is per unit cost is given, then the objective is to determine, look at this, then the objective is to determine the shipping schedule from source to destination, to minimize the transportation cost, or you can say shipping cost as small as possible. Okay sir, this is what introduction of transportation. Let us see this in a tabular form so that you can get it properly. What is given in the question sir? Manufacturer is producing the goods at various factories F1, F2, F3. Let us say 3 factories we have. The goods which are produced at these 3 factories, he is selling in 4 markets. M1, M2, M3, M4. Supply or availability at each factory is known to us. At the same time, demand or requirement at each market is also known to us. Demand at each market is known to us. Supply is also given, or it is known to us. In addition to this, per unit transportation cost is given C11, C12, C13, C14, C21, C22, C23, C24, C31, C32, C33, C34. This way per unit cost is also given. Let us see sir, C11 stands for what? Cost of supplying 1 unit from F1 to M1. C11 stands for what? Cost of supplying 1 unit from factory 1 to market 1. C12 stands for what? Cost of supply 1 unit from factory 1 to market 2. From factory 1 to market 2. This way you can interpret the values for the others. Okay, let's consider this example one more time. A manufacturer is producing a single product at 3 places. Let us take these 3 places as factory 1, factory 2, factory 3. Goods which are produced at these 3 factories, he is selling in 4 markets: M1, M2, M3, M4. Supply at each factory is known to us. Demand or requirement at each market is also known to us. Supply at each factory is known to us. Demand at each market is also known to us. In addition to this, what additional information is given here, sir? Per unit cost is given. Per unit cost is given. C11, C12, C13, C14. What is meant by C11? Cost of supplying 1 unit from factory 1 to market 1. C12 stands for what? Cost of supplying 1 unit. Cost of supplying 1 unit from factory 1 to market 2. So this way you can interpret the other things. Okay, now what is required for me? I have to prepare a schedule. In which way I have to supply the goods. From these factories to these markets to minimize the transportation cost. Again I am repeating, sir. What is required in the question? We have to prepare a schedule. What is the schedule? In which way I have to supply the goods from factory 1, these factories to these markets, in order to minimize the total transportation cost. So objective function is minimization of cost when a cost matrix is given, or maximization of profit when a profit matrix is given. Okay, sir. Now there are 2 solutions for a transportation problem. There are 2 solutions for a transportation problem. First one is initial solution. Second one is optimal solution. Look at this point one more time. There are 2 solutions for a transportation problem. First one is initial solution. The next one is optimal solution. First we have to calculate an initial solution to the given problem. Then it is developed for optimality. That is, it is developed to get optimal solution. Fine, sir. How to get an initial solution? Initial solution is obtained by using any one of the 3 methods. Initial solution is obtained by using any one of the 3 methods. First one is northwest corner rule. First one is northwest corner rule. Second one is least cost method. Third one is Vogel's approximation method. Okay, you can obtain or you can get initial solution either by using northwest corner rule or by using least cost method or by using Vogel's approximation method. In the exam they will specify which method we have to use, but here one question I will solve by using all the three methods to obtain an initial solution to the given a transportation problem. Okay sir, let's see. Obtain initial solution to the given transportation problem. Given a transportation problem. Let's see sir, there are 4 factories F1, F2, F3, F4 and also 5 markets M1, M2, M3, M4, M5. Supply at each factory is given in the question. Demand or requirement at each market is also known to us. Let us see the per unit cost. 12 rupees, 8 rupees, 1 rupee, 10 rupees. 4 rupees, 1 rupee, 12 rupees and 15 rupees. 9 rupees, 6 rupees, 4 rupees and 6 rupees. 5 rupees, 6 rupees, 7 rupees and 9 rupees. 9 rupees, 7 rupees, 7 rupees and 1 rupee. Demand at this market is 40. Here it is 20. Here it is 50. Here it is 30. Here it is 40. Now, supply at this market is 55 units. This is 45 units. This is 30 and this is 50. This is my transportation problem. Okay sir. Now look at the question once again. There are 4 factories given in the question. And how many markets we have? 5 markets we have. 5 markets we have. M1, M2, M3, M4, M5. Demand at each market is given. Availability at each factory is also given. Fine. In addition to this, per unit transportation cost is also given. Per unit transportation cost is also given. What is required for me? I have to prepare a schedule. Okay sir. See the solution. Before moving into the solution, verify whether it is a balanced problem or not. Only balanced problem has solution. Only balanced problem has solution. What is a balanced problem? When total supply is equal to total demand, when total supply is equal to total demand, then it is a balanced problem. Otherwise, it is unbalanced problem. Otherwise, it is unbalanced. When it is an unbalanced problem, what to do, that I'll take up in my coming videos. Right now, I'm concentrating only on balanced problems. Let us see the demand here, sir. 40 plus 20, 60 plus 50, 110, 140, 180. Total demand is equal to 180 units. Total demand is equal to 180 units. Total supply is equal to 55 plus 45, 100, 130, 180. Total supply is equal to 180. So total demand is equal to total supply. So it is a balanced problem. It is a balanced problem. So you can proceed for the solution. Fine, sir. Now first I am using northwest corner rule. Initial solution by northwest corner rule. Initial solution by northwest corner rule. So let's prepare the solution to the given question by northwest corner rule. Now see the question. For this northwest corner rule, consider the left hand side corner cell. Left hand side corner cell. This is left hand side, topmost, top side, this one. Now look at this. Availability at this factory is 55 units. Availability at this factory is 55 units. And requirement at this market is 40 units only. Requirement at this market is 40 units. So we can fully satisfy the requirement of market 1. We can fully satisfy the requirement of market 1. Fine, sir. 40 units are supplied here. 40 units are supplied. So requirement will become 0. Availability is reduced to 15. Availability is reduced to 15. Fine. Now this market requirement is fully satisfied. This market requirement is fully satisfied. Therefore, eliminate this market from the picture to avoid any confusion. To avoid any confusion, eliminate this market from the picture. Now, sir, how many more units are available? 15 more units are available at F1. Market 1 requirement is fully satisfied. Therefore, supply the goods to market 2. Again, I am repeating this point. Market 1 requirement is fully satisfied. So, you can supply the goods to market 2. From which factory? From F1 only. At F1, still 15 more units are available. Therefore, 15 units are supplied. Requirement is reduced to 5. Availability now will become 0. Capacity at F1 is exhausted, means it is over. You cannot supply the goods from F1. So sir, I am eliminating this factory from the picture. I am eliminating this factory from the picture. Now, market 2 still require 5 more units. Market 2 requires 5 more units. Supply the goods from second factory, because at factory 1 capacity is exhausted. 5 units are supplied. Requirement now will become 0. Availability reduced to 40. Availability now reduced to 40. Market 2 requirement is fully satisfied. Market 2 requirement is fully satisfied. It is eliminated from the picture. It is eliminated from the picture. Now at F2 still 40 more units are available. Supply goods to market 3. What is the requirement at market 3? What is the requirement? 50 units. What is the availability at F2? 40 only. So 40 units are supplied. Requirement reduced to 10. Requirement reduced to 10. Availability now becomes 0. Availability at F2 is 0. It means you cannot supply the goods from F2 to any market. F2 is eliminated from the picture. F2 is eliminated from the market. Sorry, F2 is eliminated from the picture. Now, market 3 still require 10 more units. Market 3 still requires 10 more units. So 10 units are supplied from factory 3. Its requirement is fully satisfied. Availability at F3 reduced to 20. Availability at F2 reduced to 20. Now sir, market 3 requirement is fully satisfied. Eliminate this from the picture. Eliminate market 3 from the picture. Now move to market 4. Move to market 4. How many units are required? 30 units are required at market 4. But how many units are available at F3? 20 only. So supply 20 units. It is 10. It is 0. Capacity is over. It means you cannot supply the goods from F3 to any market now. So to avoid any confusion, eliminate market 3 from the picture. Eliminate factory 3 from the picture. Again I am repeating sir. At F3 capacity is exhausted. Therefore, to avoid any confusion, factory 3 is eliminated from the picture. Factory 3 is eliminated from the picture. Market 4 still requires 10 units. It requires 10 more units. So 10 units are supplied from where? M4. 0. Availability reduced to 40. Requirement now will become 0. After supplying 10 units from factory 4 to market 4, market 4 requirement is fully satisfied. So this market also eliminated from the picture. Now 40 units are available at F4. 40 units are required at M5. Now sir, demand at each factory is satisfied. Demand at each factory is satisfied. At the same time, capacities are also exhausted. So the procedure is correct. Okay. Now one more step is required here. What is that? You have to verify. You have to verify whether the solution is a basic feasible solution or not. Let's see a point here. A solution is called a basic feasible solution. Basic feasible solution when it has m plus n minus 1 number of occupied cells, where m is equal to number of rows, n is equal to number of columns, okay. Here m plus n minus 1 is equal to 4 plus 5 minus 1, 8. Number of occupied cells required, is equal to 8. Number of occupied cells obtained. How to calculate number of occupied cells obtained? Let's go to the solution part once again, sir. Here from factory 1 to market 1, 40 units are supplied. Factory 1 to market 1, 40 units are supplied. So here there is an allocation. So it is called an occupied cell. Here there is no allocation, so it is an empty cell. Any cell has some allocation, means some units you are writing this way, it is called an occupied cell. When there is no allocation, it is an empty cell. Count the number of occupied cells. 1, 2, 3, 4, 5, 6, 7, 8. Look at this one more time. Number of occupied cells. 1, 2, 3, 4, 5, 6, 7, 8. 8 occupied cells. We need 8 occupied cells, and 8 occupied cells are obtained. Number of occupied cells obtained is equal to 8. Therefore, it is a basic feasible solution. It is a basic feasible solution. Now calculate transportation cost. Calculate transportation cost. How to calculate a transportation cost, sir? Let us see. 40 units are supplied from F1 to M1. 40 units are supplied from F1 to M1 at 12 rupees per unit cost. Transportation cost is 12 rupees per unit. So these two values I'll multiply. So this is 12 into 40. Transportation cost we can calculate. 12 into 40 plus 4 into 15 plus 1 into 5 plus 6 into 40 plus 4 into 10 plus 4 into 10 plus 7 into 20, 9 into 10, 1 into 40. By adding this, you will get a transportation cost. By adding these values, you will get a transportation cost. This is 1095 rupees. This is rupees 1095. You can check up my calculations. Okay, sir. 12 into 40 plus 4 into 15 this way. It is coming out to be 1095. Okay. This is an initial solution to the given transportation problem by northwest corner. Okay, sir. So remaining part I'll take up in the next video. Thank you.